the 400 kV Loiyangalani-Suswa Project.
We are in the final touches of working on the shunt reactor.
Kazi yangu ni kufungua barabara stima ipite.
The center peg is the tower itself.
Kazi hapa sasa leo.
Currently, we are in the final touches of working on the shunt reactor, and the initial phase is complete for this substation. We have almost, let's say, 90% complete works in terms of civil works of the shunt reactor. That is the construction work that we saw there happening. And this substation is, we are anticipating that we will be using it to transmit power to Suswa substation, where now Kenyans can benefit from this magical wind farm that we have already been able to set up here.
My main role is to open the way for construction. Anyway, tunaita kazi yangu ni kufungua barabara stima ipite. You know, we are saying we are adding around 400 megawatts of power to the national grid. So by the end of the day is that the cost of, we do anticipate that the cost of power will come down. As a land economist, we are supposed to do the valuation on for land and also for the structures that had also been affected by the wave. When it comes to the wave corridors, there are three components that we need to look at for compensation. One of them is the issue of land. The other components that we also have to value is the issue of structures that are within the wave corridors. The other component is the issue of crops.
I came to know Kentraco some years, somewhere 2010 or thereabout, when they were having the survey of an electrical line that was to run from Turkana, and it had to pass through my land. We were briefed on the impact the line would affect us, those that were within that line from Turkana to Suswa. We had to meet frequently so that they believed us on what they were supposed to do. Asante.
Right now we are at Losuk area. To be specific, we are at Lolmolok. In a transmission line, we normally check so much on the lines. First of all, the lines of the whole transmission line. Secondly, we look at the lines in the transmission tower. That is, we normally work with the main line and the 90 degrees from the line. And to get that, you have to have at least a center peg. The center peg is the tower itself. So at the center peg, we normally have four things. That is the four legs of the tower. That is where we shall raise our tower from.
This is the 400 kV Loiyangalani-Suswa Project. Well, there are major two steps. I can call it the surveying stage and the actual civil work. So in the surveying stage, the surveyor will arrive on site and locate the center of the tower. He will peg it, and then he will put some two other pegs. We call them directional pegs. These are pegs that are placed in the line, in the direction of the line. We will also have bisector pegs at 90 degrees. After that, we will do setting out of the foundation pits. Once the setting out is done and confirmed, actual excavation works will begin. And we will also ensure that from the center we have excavated to the required depth. Thereafter, we shall do lean concrete, which we may call blinding in building and construction. After that, we will put the reinforcement bars for the pad and the chimney. Then we will concrete the pad, ensuring of course that basic engineering quality principles are adhered to, like vibration, casting cubes for strength determination at 7 and 28 days. After we do the pad, we will stay at least 24 hours before we do the chimney. Of course, also with proper vibration and all those quality adherences. Thereafter, we will stay again at least 24 hours before we remove the foam box from the chimney. And of course, before we do the pad and the chimney concreting, we will have set up the template. The purpose of the template, of course, is to hold the stab in position. Well, the two most important things to check after you have set up the template is to ensure the levels of the stab are okay and correct, and also the diagonal, that is the diagonal measurements from one stab to the other, are also correct. So the purpose of this template is actually to hold the stabs in position before concreting of the chimney.
Kwa sasa tumesimama katika mnara 669. Tunaendelea na hiyo kazi, tuko kazi hapa sasa kwa leo. Mwaka kokoto, tunakoroga kokoto, tunachanganya kokoto na dust na simiti. Tunatumia, kuna vipimo ambavyo tunatumia hapa. Tumepewa zile cage box ambazo tunazitumia hapa. Upande wa kokoto tunaweka cage box 3. Upande wa dust tunaweka 2.5. Simiti tunaweka simiti nzima. Jana tulikuwa tunachimba, tulikuwa tunamalizia kuchimba, tukachimba tukamaliza, tukajaribu kusafisha shimo ikakuwa safi, kisha tukakoroka blinding, tukaweka blinding, tukafunga chuma. Jambo la kwanza, blinding inasaidia mchanga, inasaidia chuma isiguze wakati tunaweka chini, chuma isiguze mchanga, na pia blinding inasaidia inafanya shimo iko katika hali inafanana, shimo yote level yake iko same, yani inafanana chini. Template inatusaidia, inatupatia zile measurement ambazo zinatakana kulingana na hiyo tawa ile itakuja kuerektiwa, na pia inatusaidia kupatia diagonals za hiyo mnara venye. I think tunaweka wakati tunafanya kazi ya civil, wakati tunakoroga ndio tunahitajika tunaweka hiyo earthing kabisa. Inasaidia tawa isikuje kuwa inaweza kuwa inachomeka wakati mwingine, juu kazi ni ya stima. Tuko wafanyikazi 15, tukiwa ndani supervisor 2 na watu wengine 13.
After 28 days of concreting the chimney, the tower is cleared for erection. So what the erection contractor does is they ensure that for that particular tower, they have the right materials. There are several methods of tower erection depending on the size of the transmission line, available machinery, the ground terrain and everything. So on Loiyangalani-Suswa, majorly we are using two methods. There is the crane method and there is what we call the sectional method. So what the contractor does is that they come, the lower part is called the base or the basic body. So they erect from down upwards. So they erect the basic body, then they erect what we call body stage 3, 2 and 1 in that order. Then that straight part which looks like a cage is called the head stretch. Again it has head stage 3, head stage 2 and head stage 1. From there, after that they fix what we call the cross arms. The cross arms are the horizontal structures that will hold the insulators. After erection is done, the contractor will do tightening of the tower. Tightening is done from top coming down. So the contractor will tighten the tower, tighten the bolts to ensure they are at the right torque. And at the lower side, we use anti-theft nuts to about 3 meters of our chimney, from our chimney. The purpose for that is because they are difficult to unfasten, so cases of vandalism will not be experienced. So after erection is done, there's a team that will check that all the nuts are tightened and all the bolts are tightened. After that, the tower will be cleared for stringing. Now, after the tower is cleared for stringing, the insulators will be hoisted into position. On Loiyangalani-Suswa, we have 3 pairs of cross arms. Each cross arm carries an insulator, and that insulator has a roller at the bottom that will carry 3 conductors. Effectively, on this Loiyangalani-Suswa, we have 20 conductors. 18 electric carrying conductors. We have the optical ground wire, what you may call the OPGW, and the earthing wire. So after that, the pilot wire, this is the wire that pulls the conductors, will be rolled over the rollers on a track that is called the puller. On the other end, it is attached to a tensioner. The tensioner is what will ensure that we get the right sag, for every section. So the puller will pull the conductor over the rollers, and stringing is done from one angle tower to another angle tower. That constitutes a section. So after the puller pulls, the tensioner will ensure that we get the right sag for every section. So after that is done for all the sections, there will be fixing of the conductor on the 2 terminal towers of the line, what we call the dead end towers. In the case of Loiyangalani-Suswa, it is the tower at Loiyangalani and the tower at Suswa.
The Loiyangalani-Suswa line, that one is a line that is very important to the country, because we have a lot of power here that we need to be transmitting to the rest of the country. Once the line will be energized, I think this one will go a long way in providing the needed power that is required in the whole country, so that we can run our economy and also industrialize. We are working very hard to ensure that we meet the target or the time schedule that has been given to us, and we want to assure the country that with the help of the contractor NARI, we are going to deliver this project in time. Me together with my family, we are actually very happy with the Kentraco. To me, I'm happy with the Kentraco because they have actually uplifted me from the lifestyle I was in to the lifestyle that I'm in today. I can say that Kentraco came to assist me and uplift me to a level I never expected to be within such a short time.
Loiyangalani-Suswa is a project that is close to heart to most of us because it is a unique project. The first time we are evacuating energy from a wind farm. It is also the largest of its kind in Africa. So it is a line we are very proud of. We are proud it is coming to a positive conclusion. We hope it will be sustainable. It will feed the national grid, and more of the kind can be done in Africa and beyond.